Okay, this problem is Zumdahl 1319, and what we're asked to do here is to take the equilibrium constant and find new ones based on this original equation, and it's just been modified in some way. So the first thing that you need to know is that if an equation is multiplied or divided, all we do is we take the k value and we raise it to whatever that factor is that we multiplied the equation by. So in this one, we went from n, which would have had a coefficient of 1, to 1/2, and 3 to 3/2, and 2 goes down to 1. So all we're going to do is take k and raise it to the half. So that's going to give us a new number for k here, which is going to be 0.11. Another rule that we have is if it is flipped, we need to do 1 over k. So in this equation, we took the original and we flipped it, so that's going to require us to take 1 over k. And if you look at it, you can also see that it went from 1 to 2, from 3 to 1, oops, just kidding, 1 to 1, and 3 to 3. So it didn't change at all. All we need to do is do 1 over k. Sorry about that. So when you calculate here, it's going to give you a value of 77. There's a third transformation that could happen, and that is if we give you the k for two equations and somehow those two equations combine to make a new equation. And if that happens, you can multiply the two that combine. So whatever the k's are, you just do k1 times k2, and that's going to give you the k for the total reaction. Okay, well, it might be better to write these down, sorry. Because we're not raising k to those powers, we're just multiplying.